Hello. We're going to spend another day on 4.2, theoretical probability. So let's put the date. Happy birthday to those who have a birthday today. Goals. Distinguish between different approaches to probability questions based on keywords. All, at least, exactly. Determine the probability of sums. Note number 1. The theoretical probability is also referred to the classical definition of probability. They both find the probability of event A using this formula. So we've seen that formula a couple times now. So the probability of event A is your desired outcome. Okay? So the probability of A is your desired outcome. So like the cookie jar example, okay? Want to know what are the chances of getting a chocolate chip cookie? The N of A is the number of total desired outcomes. N of A is the number of times that outcome A occurs. It's also called the event space. So if I had 15 cookies that were not the chosen ones, but 5 were chocolate chip, then 5 would be the number representing the number of desired outcomes. So I had 5 chocolate chip cookies. N of S is the number of all possible outcomes, also called the sample space. So if I had a total of 20 cookies in the jar, N of S would be equal to 20. Example 1. Each letter that spell Win at South are written on a separate piece of paper of equal size. The letters are put into a hat, and that hat is shaken. Determine the probability that a T is selected. So the probability of getting a T is equal to the number of T's divided by the number of total letters. So we've got 1 T, 2 T's, total letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have to reduce it. Divide 2 by 2 to get 1. Divide 10 by 2 to get 5. So the probability of selecting a T randomly is 1 out of 5. Determine the probability that an N is selected. So the probability of getting an N is the number of N's divided by the total number of letters. So in this case, there's 1 N. We already counted to see that there were 10 letters. So that's the probability of getting an N. 4 coins are tossed in the air at the same time. Find the probability that all 4 coins are tails, at least 1 is heads, and exactly 3 are tails. Okay, so if I think of this in terms of a tree diagram, I'm gonna draw it here, try to straddle between the 2 questions. Okay, so if this is my starting point, okay, and I say that in my first coin, okay, coin number 1 I go to, I've got a head or a tail, okay? And let's say my coins are all stretched out, spread out. So from coin number 1, I have to go to coin number 2, and I could see that coin number 2, it could be a head or a tail. But if after coin number 1 was found to be a tail, and I go to coin number 2, it could be a head or a tail. So these are all the possible scenarios. I could have found that coin 1 was a head and coin 2 was a head, or I could have found that coin 1 was a head and coin 2 was a tail. So this is like a road map, okay? And at each point in my tree diagram, the branch represents the probability of getting a coin toss of a head. So it's 1 head is my desired outcome out of 2 possible outcomes. So the probability of getting this outcome to be a head is 1 out of 2, right? And so is this. And so each branch is a result of a probability of 1 out of 2, okay? But we didn't just flip 2 coins, we flipped 4. So at coin number 3, I could see that I had a head or a tail, but if after flipping, or if after looking at coin 1 and 2 I got a head or a tail, I could have also for coin 3 gotten a head or a tail. But again, this is all laying out for us all the possible combinations, okay? So after my coin number 2, so this is all possible combinations of coin number 2 as a result of getting possible combinations for coin 1. So coin 2 over here could have left us again with a head or a tail, and this could be giving us a head or a tail. Okay, so coin number 4, okay, I could have gotten a head or a tail, 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 a head or a tail. So notice we've got all these branches that give us, in fact, the same probabilities between each of the branches. So what I'm saying is that if you're flipping coin 3, okay, and you want to know what are the chances of getting a head out of all the possible outcomes, well, the coin could be a head, okay, that's your desired outcome, out of the 2 possible outcomes, which is a head or a tail. So all of these branches is a result of 1/2. And these are all 1/2. Because your action is the same, right? Okay. So what's the probability that all 4 coins are tails? So A, the probability you get 4 tails. Okay, so where are the tails? The tails are here. 1, 2, 3, 4. 4 tails. So it's a result of multiplying all of the probabilities along the branches that you travel. So 1, 2, 3, 4 branches, each with 1/2. 1/2 times 1/2 times 1/2 times 1/2. Okay, so multiply the numerators together to get 1, multiply your denominators together to get 16. So the probability of getting 4 tails is 1 out of 16. Now, if I want the probability of at least 1 that turns up a head, that's equal, so at least is equal to the probability of getting 1 tail, but it's also added to the probability of getting 2 tails, which is also added to the probability of getting 3 tails. Now, there's lots of ways that you could get 1 tail. You could get a tail followed by 3 other heads. You could get a tail on the 3rd coin toss with all the others being heads. You could get a tail on the 4th coin toss and all of the others being, so there's lots of combinations. Now, you can see there are tons of branches here, and I don't want to take more time than is necessary to answer this question. If we think about what this is not, we could use the complement. So if I say I want the opposite of at least 1 is heads, and I look at all these things here, what is the probability that is left out? Because what is left out is what I could subtract from 1. Well, because we have uh, 4 coins, it's also equal to the probability of 4 tails. Oh my goodness, it even makes it longer. Okay, so I think of all these possible scenarios, the only one that's missing is 0 tails. So take the complement of at least 1 is heads. That's the same as 1 minus 0. Probability of 0 tails. Because that's the only one that we don't want. Well, that's the same as 1 minus the probability. If I have 0 tails, that means I have 4. Oh my goodness. I used heads. Probability 1 head. Probability of 2 heads. Probability of 3 heads. Probability of 4. There we go. Okay, gotta make sure I'm reading the question. Okay, so if we look at all this, we can say the only thing that's not included from all of the probabilities is 0. If we take away 1, all the probabilities, minus 0 heads, we have actually answered the question. So this is the same as 1 minus the probability of 0. 0 coins coming up as a head. Well, that is the same as saying 1 minus the probability of 4 tails. That's why I wanted to see about the tails. Well, we already have that answer, which is here. Okay, so it's 1 minus 1 over 16. 1 becomes 16 over 16 minus 1 over 16. 15 over 16 is our answer. Okay. All right, what about C? Exactly 3 are tails. So the probability that you get 3 tails. Okay, so that's a head, so that won't work. So that's a head, that's a tail. That's a tail, and that's a tail. So that one, that one, that one, and that one. So that's 3 tails. Okay, so I want a tail. So I want 3 in total. So 1, no, that's not enough. That's 2, and that's 3. So that's 3 tails. So you have to look, right? You're searching. It's like finding the best cookie, best outfit, okay? So then 3 tails. So there's 1, 2, and then here that would be 3 tails. And then what else? There's 3 tails. That's the head. Okay, so there's 3 tails. So just checking. So it's 3 tails only allows with 1 head, right? So as soon as we get a second coin that's a head, it disqualifies itself. So, oh, that's too many heads. Okay, so that's the one we're just checking. Too many heads. So this one here, that's 2 heads, 2 tails. That's the 3rd tail. There's 2 tails, 3 tails. Okay. So reading off the branch, that's a half times a half times a half times a half. And we have 1, 2, 3, 4 groups of them. So we have 4 groups of 1/2 times 1/2, 1/2 times 1/2 times 1/2 times 1/2. So 4 groups of, multiply the tops, multiply the denominators, so 4/16. Okay, and reduce, divide by 4, 1/4. 2 dice are rolled. I think I better upload this portion of the video and then I'll upload the next part in a second.